All right, in example 1, we're looking at a second-degree linear homogeneous recurrence relation. I know that because I have my linear values here, my constants, and I've got 2 previous terms. Got my initial values here, so when I want to determine the first 6 terms of the sequence, I know u1 is -1, u2 is 1, u sub 3 times 1, u to the n minus 2, sorry, 3 times -1 plus 2 times 1 is -1, u sub 4, 3 times 1, 2 times -1 is 1, u sub 5 is going to be -1, and u6 is +1. Later in the course of this topic, we're going to look for sort of general rules or relations about first-order linear recurrence relations, second degree, but we don't have to memorize those rules. Instead, we can always list out enough terms that we can start to see a pattern to also help us find a general term. So our general term is going to be written in terms of n rather than using previous terms. So it seems pretty obvious to me that our general rule is u sub n equals -1 to the n power. All right, so I want to prove that using strong mathematical induction. So our statement is given. un is -1 to the n if un is 3un minus 2, 2un minus 1 with initial conditions. I'm not going to copy those down. We can see them up above. All right, we know it's true for n equals 1 and 2 because we've shown that up above. We're going to assume that it's true for all I, not some. 1 less than or equal to I, less than or equal to k. Now we want to show it's true for n equals k plus 1, that our u sub k plus 1 is equal to -1 to the k plus 1. So that's what we want to show. And I'm going to start with u sub k plus 1 is equal to 3 u sub k minus 1 plus 2 u sub k. Based on my assumption up here, then I can say that's equal to 3 times -1 to the k minus 1 plus 2 times -1 to the k. I'm going to factor out -1 to the k minus 1. That's going to leave a 3 here. 2 times -1 to the -1. -1 to the -1 power, well, that's 1 over -1, which is -1. So 3 minus 2 is 1. -1 to the k minus 1 times 1. I would really like this to be a -1. I know that 1 is the same as -1 squared. Now using my exponent rules, this is the same as -1 to the k plus 1. The last step that's missing in my induction is to write my conclusion statement. So hence, since it's true for n equals k plus 1, and it was assumed to be true for all of these, was also true for the first 2 terms, that must mean that these were all true. Since this was true, therefore our statement must be true. So I don't have enough space to write all that. I'm going to leave it here for you to fill in yourself. Again, you can see that in the completed notes as well.